Good morning, class. Um, so today we are going to be looking at ammeters and voltmeters again. So I've talked about these types of meters before when we were looking at our electrical circuits and circuit diagrams, and we talked about the fact that ammeters will measure current flowing in a circuit, whereas voltmeters will measure potential difference or voltage within electrical circuits. Now, unfortunately, you guys will not have that opportunity to make circuits using an ammeter and a voltmeter in class. You might have built these before in earlier grades, but we were going to do a number of different investigations using electrical circuits and parallel versus series, using different light bulbs and a number of different wires and switches and multimeters. But unfortunately, we can't do that. So I think it's an important skill to be able to use one. So I wanted to go over this with you. So you have this, you have these pages with you in the Google Classroom post, classwork post, and I'm going to go through and fill in the blanks for you so that you can fill in your sheets. So please have these pages ready. So using ammeters and voltmeters. So the terminals of a meter. So all terminals, basically these things right over here, basically have two connecting points. So all meters basically have two terminals or connecting points, and there is the positive terminal. And I apologize, my writing is going to be difficult because I'm writing upright again. And this, as you probably have, know this from before, but this is usually represented with the color red. And then you have the negative terminal, which is usually represented by the color black. Okay. So for both voltmeters and ammeters, the positive terminal red of the meter must trace back to the positive terminal of the source, which is your battery or cell. Like in this case, this is a battery. It's probably made of at least 2 or 3 cells, and so this is right over here in your ammeter. You see this is the positive symbol, positive sign, and this red wires, which are, represent the wires that you should connect. Well, it doesn't really matter what color the wires are. Wires are wires, but this is just showing you that this positive terminal is connected directly with the positive terminal of that battery. Okay, and similarly, the negative terminal, which is the black, the terminal of the meter, must trace back to the negative terminal of the source. Okay, so this right here is the negative terminal of the ammeter, and it's directly linked to the negative terminal of that source, of that particular battery. So that's really important when you're connecting. Many students, when they're starting to use meters, ammeters, or voltmeters, there's always a few of you that will put the positive connection with the negative connection, and then you get a reading that is negative on the ammeter or the voltmeter. Okay, so that's really important. So when you're connecting an ammeter, we know that the ammeter is used to measure current, which is, I'm so sorry about this, it's basically the amount of charge, so those groups of electrons passing a given point per second at a particular point within that circuit. And an ammeter is always inserted in series. Okay, it is inserted along the path, along in between the wire, in between the wiring, and not like a voltmeter, which is attached across a load or across a source. Okay, so you have, if you use this diagram, we can draw a an electrical circuit diagram with just symbols. So this is your switch, okay, and then right over here, there's your switch. You've got a connecting wire. An ammeter, as you know already, has that symbol, circle symbol with an A, okay, and then you have another wire that is going from the ammeter, and basically you have this bulb right here connected to that ammeter, which is eventually connected to that source, which is a battery, so it has to have at least 2 or more cells, and then this negative terminal of that battery is connected to that switch. So notice that when we connect this ammeter, it's the negative terminal of this battery right over here has to be indirectly attached to the negative terminal of that ammeter, and the positive is attached right here to directly with the positive terminal of that battery. Okay, now looking at the voltmeter now. So a voltmeter is basically a device. Voltmeter is a device used to measure potential difference, or also known as voltage. Oops, spelled voltage wrong. This is so difficult to write upright. Anyways, voltage between 2 points within a circuit. And the voltmeter, as you know, is always connected in parallel, or as we know, across 2 points in a circuit, across the load or across a battery or a cell. So you connect the terminals of the voltmeter to the 2 connections of the component where you wish to measure the potential difference. So for example, this voltmeter here is, we want to measure the potential difference between this part of the before the current goes through the light bulb compared to when the current leaves the light bulb. Okay, and it has to be, again, connected the same way. The positive needs to be connected to the positive terminal of the battery, and the negative terminal has to be connected to the negative terminal of the battery, which is all the way over here. Okay, but the only thing is that it's placed not within the actual wiring, but it's across that light bulb, because it's measuring the difference between here and here. Okay, so I should get rid of that. All right, so how do you read a meter then? Because there's a scale that you really are looking at when we're reading a meter. So the scale on the analog meter can be changed by how the wires are connected on the terminals or by turning a dial. Okay, so in class, what we usually do is we use our connecting wires and we place them. Let me show you. We have those prongs on the wires that they connect. That you squeeze them and they can these little screw caps here, you move them so that the prongs can go underneath the caps and have contact with the metal. And these screw caps are usually they have plastic on top so that it can be protected. It needs to be insulated. So what we do when we using an ammeter, for example, we look at the you need to set the meter on the largest scale to obtain approximate value. Then we will lower the scale until you have the highest possible reading without going off the scale. Okay, so sometimes these when you've plugged it in, you've connected it incorrectly, you sometimes get your dial that goes right off the actual scale. So you know you've put the connecting wires in the wrong at the wrong setting. Okay, so you have to kind of work in a more organized fashion. Okay, so once you've done that, once you've found the scale that you've got the highest possible reading, so you look at the number at the top of the scale with the same digits as the setting, and then you determine which number the needle is pointing to. So for example, in this case, in this ammeter right over here, we have connected with the 50 milliamps, okay? So it's from 0 to 50. So that the scale, let me just erase this, the scale, hold on, I'm going to take this off my, excuse me a second. This might be easier to read now, so if I can do this. So my scale using this setting is 0 to 50 milliamps. Okay, so in order for us to be able to, so this is where it's so we're not going to be using the top values. We're not going to use that top scale, and we're not going to be using this one either. We're going to be using, let me see if I can change the color. We're going to be using I guess not, sorry. We're going to be using here from negative, but 0 to 50 milliamps. And we need to figure out what each of these unit markers, these tiny unit markers, represent. So we can do that by doing a simple division. So what I do is basically I do 50. I use the first from the 50 milliamp marking. I kind of work backwards. So I do 50 minus 40 to figure out what those unit markers represent from here to here. Okay, and that doesn't look very good because it's not tracing very nicely now. That's weird. Okay, well anyways, and then basically because there's 10 10 markers, I would divide it by 10, which is equal to 10 over 10, and each of them equals 1 unit. Okay, so when I'm really sorry, I don't know how I'm going to erase this, but you can see that from 0, this setting right over here, that the needle is pointing just before 5. It's pointing right over here at the marking, which is represented by 4 units. So the answer to the scale on this ammeter would be -4 amps. Okay, that would be the reading for that ammeter, because you're going, you basically got a negative value using this scale, 0 to 50 milliamps. Okay, on the right over here, diagram B. Okay, so we are using this 0, and we're using the 3, the marker that has the number 3. Okay, 0 to 3 scale. And so we are going to be using the one in the middle. So when we look at the one in the middle, it's basically going from 0 to 1, 2, and 3. So in order for us to find out what each of these little unit markers represent, we would do the same thing. So first of all, the scale is 0 to 3. Okay, and this one is not amps, it's actually measuring volts. Okay, 0 to 3 volts. And the division, sorry, my writing is so bad, would be 2 minus 1, or sorry, 3 minus 2. Okay, because I'm going to be looking from here to here. It's the same thing, but anyways, 3 minus 2 over 10, because there's 10 unit markers, which is 0.1. And each of those little markers represents 0.1. So when I look over when I look over here, basically I know that it's going to be 1 point something, and each of these represents 0.1, so it's going to be 1.1, 2, 3, 4, 5, 6, 7. So 1.7 volts is my reading for this voltmeter. Okay, and I have to erase that now because that's affecting the next question. Okay, the next scale, this is C, and this is another ammeter, and the scale is basically that what we're using is it's going to be 0 to 5. Okay, there's the 5 amps, 0 to 5 amps. Okay, and then the division to figure out what each of those unit markers represents. We will look at the number 5. We're going to use the top scale right over here. So 5 minus 4 over 10 is equal to, again, 1 over 10, which is equal to 0.1. So we're looking at this scale reading over here, and each of those is represented by 0.1. So the dial is actually right between, so this is 1, 2, 3. It's right between 3 and 4. So my ammeter reading is equal to 0.35 amps. Okay, and the last one I'm going to show you right here, this is for voltage, and the scale that is being shown here is 0 to 30 volts. Okay, 0 to 30 volts. And the division, we're going to use the top scale right here, the top one. It has to be, you have to look specifically for the scale that makes sense with whichever terminal that the wires are plugged into. That's so important. So the division is going to be from 30 to 20. So 30 minus 20 divided by 10, which is equal to 1 basically, okay? So each of these spaces is represented by 1, and when you count from 0, this is 5, and then 1 over is obviously 6. So the answer to this voltmeter, or the reading of that voltmeter, is 6 volts, okay? So I'm going to erase these now, because now it's going to affect the other pages again when I'm moving up with this recording. And I believe the rest of this is exercise for you guys to complete. There's 6 of them for the scale readings for the ammeters, and there's 6 for the voltmeters, and I'd like you to complete that for homework. I hope that you're able to do this reading now yourselves, and you will hopefully be equipped for when you do this again in physics in grade 11. Okay? Have a wonderful day, and don't forget to turn your homework in. Take care.